Welcome to the deep dive. Today we're tackling something pretty important, actually, a corporate safety document.
Right.
Specifically, the Chemical Management Standard, that's EHM MPG 13, for the Electromechanical Project Group.
A big one.
Yeah, and our goal, really, for you, the learner, is to turn this dense compliance language
Into something you can actually use.
exactly, actionable knowledge. We want you to see this not as just, bureaucracy, but as a real operating manual. We're pulling out the critical layers, the responsibilities, the procedures for managing chemicals safely on these huge project sites. The who, what, and how.
And maybe we should start with the why. Why does this standard even exist?
Good point.
Well, the document itself is quite clear in the introduction. The goals aren't just internal policy. It's fundamentally about preventing accidents,
Naturally.
minimizing environmental damage, and keeping those EHS standards high. But critically, it's also about complying with the law.
The hard legal requirements.
Exactly. Things like the Factories Act, the Hazardous Chemicals Rules 2016, and even global standards like ISO 45001.
Okay, so this standard is basically the practical translator, taking those big laws and making them work day to day on site.
That's a great way to put it. It translates law into action, and we really have to stress the scope here.
Yes.
This is written specifically for EMPG project sites. It's tailored for that kind of large-scale electromechanical work, not just any site.
Got it. Customized. Okay, let's unpack some of the language then. The vocabulary is key, right? If you're on site, you need to know the terms.
Absolutely. First base.
Let's start simple. A chemical. Defined broadly, atoms, molecules, solid, liquid, gas, standard stuff.
Pretty straightforward. But the documents about the chemicals, that's where the safety system really kicks in.
Right. Two key acronyms you mentioned.
Yes. First is the Material Safety Data Sheet, the MSDS.
Yeah.
Now, the interesting thing here is who generates it. It's the manufacturer.
Not the site team.
No. It's a legal document from the maker, listing all the hazards, precautions, everything. And for compliance, the site must keep that MSDS right where the chemical is being used, physically there.
Okay, but I can see a potential issue. An MSDS can be long, technical, maybe not super user-friendly for the person actually handling the chemical.
That's exactly the challenge. They're written often with liability in mind, very detailed, so it bridges that gap.
How?
With the second key document, the Safe Use Instruction, or SUI.
SUI.
Think of the SUI as the distilled essence of safety for the user. It's usually a one-pager.
One page. That sounds manageable.
Right. And crucially, it's prepared by the site's EHS department. They take the complex MSDS info and translate it into specific, clear instructions for that particular task in that particular work area.
So it's tailored. MSDS is general. SUI is specific to the job.
Precisely. It makes compliance understandable and practical at the point of use. Manufacturer liability versus employee comprehension. That's the core idea.
Makes sense. Before we move off definitions, you also mentioned containers, secondary and transfer.
Yes, small point, but important for labeling and handling. A secondary container is basically when you pour some chemical out of the main drum or bottle for immediate use, like a small tin of paint you're using right now.
Right.
A transfer container, though, is different. It's specifically designed for moving chemicals safely between locations on site. Think a proper safety can for carrying solvent. It has to be more robust, designed for transport.
Got it. Different function, different safety needs. Okay, so we have the documents, the definitions. Let's talk about people. Who owns safety? This accountability web.
It's a very structured hierarchy, and it has to work together. It really starts at the base, with the workmen.
What's their core role?
Their responsibility is pretty absolute.
Yeah.
Attend the required training on the MSDS and critically the SUI for the chemicals they use. And then follow those guidelines exactly. Handle, store, dispose only as instructed.
Simple adherence. Okay, moving up.
Then you have site management. This includes supervisors, the site in charge, engineers, the people overseeing the work directly.
And their job is more proactive.
Much more. They have a big chunk of responsibility. They need to conduct the hazard identification and risk assessment, the HIRA, for all chemical storage, handling, transport.
Let's pause on HIRA. What does that actually involve?
It means they have to systematically think through every step of using a chemical on their site. Where could something go wrong? What's the risk? And then define the specific controls.
Like what PPE is needed or specific ventilation?
Exactly. What procedure must be followed? They have to figure that out before anyone touches the chemical. They also have to make sure the MSDS and the relevant SUI are posted clearly right there in the storage areas.
Visible and accessible. Okay. Next level.
The Project EHS representative, think of them as the system guardians for this standard.
What are their specific duties?
They have ongoing tasks, maintaining and updating the master list of chemicals for the site, and the standard says monthly.
Monthly updates, wow.
Yes. They are also the ones who take the MSDS submitted by users and actually develop that site-specific SUI.
So they create the key translation document.
Correct. And they're the central point for reporting any incidents, near misses, or unsafe acts involving chemicals up to the EHS review committee.
Okay, EHS rep manages the system. What about the top site leadership?
The project manager and project director, they have ultimate ownership of implementation on their project.
Yeah.
Meaning they ensure the resources are there, the training actually happens effectively, and this is key. They personally conduct safety observation tours, or SOTs.
You mentioned SOTs earlier. Tell us more about what happens on an SOT. What's the director looking for?
It's essentially a management spot check, but focused. They go to areas where chemicals are being used or stored. They're not just reviewing paperwork, they're observing.
Watching the actual work.
Yes. Is the worker wearing the right gloves, the right goggles, as per the SUI? Is that secondary container properly labeled? Is the SUI itself visible? Do the workers understand it? They look for practical adherence.
And then they follow up on issues.
Immediately. Findings are documented, corrective actions assigned and tracked. It closes the loop.
It sounds like accountability is baked in at every level. But then there's one more layer. Champions. What do they do if the PM and PD are already doing SOTs and ensuring implementation? Seems like overlap.
That's a really good question. It could seem like overlap, but the champions have a distinct higher-level function. They aren't focused on the day-to-day site operations like the PM or PD.
So what is their focus?
They are focused on the standard itself. Think of them as the auditors and the quality control for the entire chemical management system.
Auditing this system, not just the site's compliance.
Exactly. They evaluate if the standard is actually effective. They do this through monitoring specific metrics, conducting a formal annual self-assessment of the site's compliance against the standard's requirements.
An internal audit against the rulebook.
Precisely. And maybe most importantly, they look for opportunities to improve the process, to make the standard better. They feed into the revision cycle. They ensure the system stays healthy and doesn't just become ticking boxes.
That makes a lot more sense. They're guarding the guards, in a way. Checking the effectiveness of the rulebook itself.
You could see that, yeah.
Okay, let's shift to the actual procedures then. The physical safety steps that come out of this structure.
All right. The core flow is pretty logical. Step 1. The project team does that HIRA we talked about.
Yeah.
Planning for storage, transfer, handling, risk assessment first.
Planning complete. Then what?
Then the person or team that actually needs to use a specific chemical has to submit its MSDS to the EHS department. And critically, this is before the chemical is brought on site or used.
The trigger for the process.
Yeah.
EHS gets the MSDS.
EHS reviews it, verifies it's complete, and then prepares that simplified site-specific SUI based on the MSDS information and the planned task from the HIRA.
The translation step happens.
Yes. EHS then provides that SUI back to the user department.
Right.
And the final, crucial step in the chain. The user department must ensure that every single employee who might be exposed to that chemical receives specific training on that SUI.
Not just general chemical safety, but training on the specific instructions for that substance.
Exactly. And if a new chemical comes along, this whole cycle has to start over immediately for that new substance.
A tight loop.
Uh-huh.
Okay, what about the physical containers? Labeling.
The standard is absolute here. Labeling requirements are non-negotiable. Both secondary containers and those transfer containers we defined earlier, they must be labeled. Minimum information, the chemical name, the primary hazard like flammable or corrosive, and the standardized hazard symbol. There's even a specified format A5 size.
Clear, visible, standardized, no excuses for confusion.
None. And this leads to a really specific prohibition that's worth highlighting because it underlines the potential for simple, tragic errors.
What's...
The standard explicitly says, do not store chemicals in any type of drinking water bottles.
Wow, that seems like obvious common sense, but they felt the need to write it down explicitly.
Think about it on a busy, hot construction site. Someone finishes a bottle of water. They need a small container for some solvent or cleaner. It's right there. It's convenient.
And 5 minutes later, someone else sees a water bottle. They're thirsty.
Exactly. That momentary confusion, that lack of a clear label on something universally recognized as safe to drink, It's a recipe for disaster, an easily preventable internal injury, so the rule is absolute.
That really drives home the why behind seemingly small rules. Okay, moving to storage requirements. What are the key rules there?
It's quite detailed. First, obviously, store according to the specific guidance in the MSDS for that chemical. That's baseline.
Right.
But beyond that, general rules apply. Electrical fittings in chemical storage areas must be flame-proof.
Makes sense for flammable vapors.
Yes. The storage area itself has to be specifically designated, clearly marked, and kept separate from other combustible materials like wood or paper.
Separation is key.
Crucial. And flammable chemicals have another layer. They must be kept inside purpose-built, flame-proof cabinets, locked usually.
Right.
And probably the most fundamental rule of chemical storage, learned the hard way over centuries, incompatible chemicals shall be stored separately.
Ah, the classic example of acids and bases or oxidizers and flammables.
Precisely. Storing them together risks a dangerous reaction fire, explosion, toxic fumes. So strict segregation based on compatibility.
How is this checked?
Mandatory monthly inspections of all chemical storage areas, documented inspections. Any deviations found, like improper segregation or missing labels, have to be recorded and corrected.
Constant vigilance. Okay, last piece on physical safety. PPE.
Personal protective equipment. Every site has to develop a mandatory PPE matrix specifically for chemical handling.
So a chart that says for chemical X, use these gloves, this eye protection, maybe this respirator.
Exactly. It takes the guesswork out. It defines the required PPE based on the chemical and the task linked back to the HIRA and SUI.
Clear requirements. Are there any exemptions to this whole standard?
Just two main ones noted. Hazardous waste that's usually managed under separate specific waste regulations.
Okay.
And personal items. Things like food, drinks, medications, cosmetics that employees bring for their own use or consumption. Those obviously aren't covered by the industrial chemical standard.
Right, makes sense. Okay, that covers the procedures and physical side. Let's talk about the final piece. Keeping the system alive, the cycle of improvement.
Yes, this is where you see it's not just a static rulebook. It's about continuous management and measuring if it's actually working. Knowledge has to be applied and verified.
So how often does training happen?
It's specified. For employees actually handling or storing chemicals, they need refresher training on the relevant MSDS and SUI at least once every 6 months.
6 months. Frequent reinforcement.
Keeps it fresh. For supervisors and engineers, the managers, they need training on the overall chemical management standard itself once per year.
Got it. And how is effectiveness measured? You mentioned metrics earlier.
Right, the key performance measuring indicators, or KPIs. This is, I think, one of the most telling parts of the standard. Senior leadership, regional heads, project directors, EHS leaders review these KPIs monthly.
Monthly reviews at that level. What are they tracking?
They're tracking leading indicators, not just accidents after they happen. They are looking for failures in the process itself.
Like what specifically?
Okay, get this. One KPI is the number of chemicals used without documentation, meaning someone used a chemical, but there was no approved MSDS, HIRA, or SUI in the system for it.
Wow, tracking paperwork gaps as a performance indicator.
Exactly. Another one, number of chemicals not meeting labeling requirements. They are literally counting missing or incorrect labels on secondary or transfer containers.
That's incredibly granular for high-level review.
It shows a deep commitment to process compliance. They also track the number of employees trained on chemical handling, ensuring the training mandate is met. And finally, the compliance status of waste collection and disposal, a simple yes-no check.
So by tracking missing documents and labels, they spot risks before they cause harm.
That's the idea. Manage risk by managing the procedural details rigorously.
This all generates a lot of records, presumably.
Absolutely. The documentation trail is crucial. Things like that master list of approved chemicals, all the SUIs that have been developed, and something called the chemical compatibility matrix, which helps enforce that separate storage rule.
Who keeps all this?
These key records are typically owned and maintained by the EHS department. And the standard specifies an ongoing retention period. They are part of the site's permanent safety memory.
And the standard itself, does it get updated?
Yes, that's the final check, the system review. The standard mandates a full review and potential revision at least every 3 years from its last revision date.
To keep it current with new chemicals, laws, best practices.
Exactly. Ensures the rule book itself doesn't become obsolete.
Okay, this has been a really thorough deep dive. We've seen the critical difference between the MSDS, that manufacturer document, and the SUI, the user-friendly site instruction. We mapped out that whole web of accountability, from the workmen right up to the champions who audit the system's health.
Yeah, that structure is key.
And we hit those crucial practical rules: separate storage for incompatibles, the vital importance of labeling, and that very specific rule about never ever using water bottles for chemicals.
Little details that prevent big tragedies.
So wrapping up, what's the final takeaway here?
I think the most powerful insight from digging into a standard like this is how effective safety shifts from just reacting to failures to proactively measuring adherence to the process.
Right, the KPIs.
The fact that senior management is tracking the number of missing labels tells you everything. It shows that real compliance isn't about some abstract idea of being safe or even achieving zero incidents immediately. It's about relentless, measurable, daily attention to those low-level procedural details.
Managing the inputs to manage the outcomes.
Precisely. And maybe that leaves us with a question for you, the listener, to think about. What complex task or process in your own work or even personal life might benefit from defining and tracking a similar, maybe seemingly minor, documentation compliance or procedural adherence metric? How could you make your own safety or effectiveness more verifiable and less based on intention alone?
A fascinating thought. Turning intention into measurable action through process discipline.
That's how high reliability organizations work.